Hi students, this is Anita Raj, your chemistry mentor, welcoming you for one more session in Numericals from Chemical Kinetics, that is part 2. We shall straight away move on to the topic, students. The reaction 2N2O5 to give 4NO2 plus oxygen. The rate and the rate constants are 1.02 into 10 to the power minus 4 ms minus 1 and 3.4 into 10 to the power minus 5 s minus 1 respectively. Then concentration of N2O5 at that time will be, see, they have given the values for rate and rate constants. Two values were given and they are asking you to find out the concentration of this N2O5 at that particular time. Okay, and four options were also given. So first let us write down the given data. See what are the data given? R value. What is R value? 1.02 into 10 to the power minus 4. Is it not? Ms minus 1. And then what else is given? In rate constant. K value is also given. K is equal to 3.4 into 10 to the power minus 5. Is it not? And they are asking you to find out the concentration of N2O5. Okay, they are asking you to find out the concentration of N2O5. See, for that you should know the rate expression, right? What's the rate expression? Rate is equal to rate constant into concentration of N2O5. Okay, concentration of N2O5. On the reactant side, we are having only N2O, right? So now we can write down the values. The values are given. Rate R values given and K values are given. So it's a simple problem. We can directly note down the values. It is 1.02 into 10 to the power minus 4 is equal to, what is K value? It is 3.4 into 10 to the power minus 5 into concentration of N2O5. Okay, so two values are given. Now you are in need of N2O5 concentration alone. So you can make use of these two values and simplify and find out the answer. So the answer is 3 molar. The concentration of N2O5 is 3 molar. So the option B is correct. Understood, students? Read out the next question, students. What is the activation energy of a reaction if its rate doubles when the temperature is raised from 20 degrees centigrade to 35 degrees centigrade? See, they have given the R value 8.314 joules per Kelvin per mole. Okay. See here, this value, what they have given us, the rate is getting doubled. That's a clue they have given, and they are asking you to find out the activation energy, and four options were given. See, let us write down the given data first. What is T1? What is T1? It is 20 degrees centigrade. Is it not? It is 20 degrees centigrade. And what is T2? And if you want to convert this into Kelvin scale, it becomes 293. Okay, 293 Kelvin. And okay, what is T2? It is T2 is 35 degrees centigrade. Okay, and when you are converting to Kelvin scale, it will be 308. Okay, 308 Kelvin. Okay, now what they have given, the rate of the reaction is getting doubled when the temperature is raised from 20 to 35 degrees centigrade. Okay, so rate of the reaction, let us consider the rate of the reaction at T1 as R. Okay, and this rate of the reaction is getting doubled at T2. So we can write as 2R. Okay, so what could be the rate constant during the first temperature? It will be K1. Okay, let it be K1. And here rate constant for a temperature T2 will be K2. Okay, now we understood. So let us write the formula now. What is the formula which relates the rate constant with that of the activation of energy? It is log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T1 T2. So now this is the formula. Now we know that what is K1? It is R, right? What is K2? It is 2R. I'm going to substitute those values. So this equation becomes log 2R by R is equal to EA by 2.303 R into T2 minus T1 by T1 T2. Understood? T1 T2. Now when you are simplifying this becomes log 2. Log 2 is equal to EA by 2.303 R into T2 minus T1 by T1 T2. Understood? Now we are going to substitute all the values. What are the values? What is log 2? It is nothing but log 2 is 0.301. Is it not? Is equal to EA by 2.303. 2.303 into 8.314. Is it not? Our value is 8.314. It is given in the problem. Now, what is T2? It is 308. 308 minus 293 divided by, what is this? 293 into 308. Is it not? So now substitute, now simplify. You can bring this EA this side, so that it becomes like 0.301 into 2.303 into 8.314 into 293 into 308 divided by, what's the difference between these two? 615. Is it not? So when you are simplifying this, you'll be getting 34673.4. See, what's the unit for this one? Joules per mole. See, if you want to write in kilojoules, then this answer becomes 34. You should divide by 1000. Okay. If you want to convert this joules per mole into kilojoules, you should divide by 1000. So this becomes 34.7 kilojoules per mole. Understood, students? This is how we should do the problem. So what is the answer? This option B is correct, right? 34.7 kilojoules per mole, right? Read the next problem, students. The slope of the line graph of log K versus 1 by T for a reaction is minus 5841 Kelvin. Calculate the energy of activation for this reaction, and the R value is also given. See, slope is given and R value is given, and you are asked to find out the energy of activation. Okay. So, and 4 options were given. Let us write down the data first. What is the slope given? Slope is minus 5841 Kelvin. Okay, and R value is given 8.314. Okay, R value is 8.314, and you are asked to calculate EA. So what is the formula which relates this slope with that of EA? It is slope. We'll write the formula. Slope is equal to minus EA by 2.303 into R. Okay, and we are in need of EA. Okay, so this equation becomes minus 2.303 into slope into R. Okay, so just to substitute all the values, students. Minus 2.303 into, what is the slope value? Minus 5841 into 8.314. Is it not? So the answer is, this answer EA is, see, when you are simplifying, you will be getting 11838.4 joules per mole. So the unit for EA is, in activation energy, is joules per mole. If you want to convert this into kilojoules, you should divide by 1000. So this becomes 11.838 kilojoules per mole. Understood, students? So the correct option, which is having the correct option 11, this one, the option A is correct. Understood, students? Read the next question, students. Determine the order of the reaction C12H22, that is sucrose plus water in the presence of an acid. It gives C6H12O6 plus C6H12O6. From the following data, say a data has been given. From the following data also, calculate the rate constant of the reaction. See, we are supposed to find out the order of the reaction and also the rate constant of the reaction from the following data. So what are the data given? Time in minutes given. So different time intervals, 30 minutes, 90 minutes, 230 minutes, and at infinity. And polarimeter reading in degrees. Okay, rotation in degrees is given. Okay, so plus value, plus value, plus value, plus value, and it's a minus value. So different data are given, and you're supposed to find out which type of order or which type of reaction it is, and tableau column, then it will be easy for you to do the problem. Okay, so let me write the first one. What is the formula? I'm going to write. See, I have given the formula here. 2.303 by T log R0 minus R infinity divided by RT by R infinity. So now I am going to write what is R0. What is R0? What is R0? It is plus 46.75. Is it not? What is R infinity? See, R infinity is minus 18.75. Is it not? So now I'm going to see this value will be changing for individuals. Okay, for different time intervals, this value will be changing because t value is changing here 30, 90, 230. But here this value will be a constant or 0 or infinity. Okay, it will be a constant value. So I'm going to find out this value, right? So r0 or infinity. R0 minus R infinity is equal to, what is R0? It is plus 46.75 minus 18.75. So when you are simplifying this, you'll be getting the value 65.5 degrees. Okay, so this value is 65 point r0 minus r infinity 65.5. Now we can make this value, the values of k at different intervals can be calculated by using this tabular column. Okay, let me write the different time intervals now. So what is the first one? It is 30. Here it is 90. Here it is 230. So for different time intervals, we are going to find out. What is the rotation? What is the rotation at 30 degrees? It is plus 41.0. Is it not? The next one is plus 30.75. Is it not? Next one is plus 12.75. Understood, students? Now we are going to find out the difference between RT minus R infinity. That is between this value and R infinity. Okay. So let me write that value 41.0 minus of minus 18.75. So when you are finding the difference, you will be getting 59.75. Understood? So okay, next value it is 30.75 minus 18.75. So when you are finding out the difference, the answer is 49.5. Okay. So what's the next one? It is 12.7. Is it not? 12.75 minus 18.75. So the value is 31.75. So we have found out this RT minus R infinity also. So now we are going to substitute these values. So K is equal to 2.303. What is the T value? It is 30 log. What is R0 minus R infinity? It is 65. Is it not? It is 65. It's a constant value, 65.5. Is it not? So 65.5 divided by 59.75. So when you are simplifying, you will be getting the answer as 3.06 into 10 to the power minus 3 minutes minus 1. See here, for rate constant, it is either second minus 1 or minute minus 1 or hour minus 1 or year minus 1. Okay, whatever the unit given, you should make use of, right? So let us calculate for the next one is equal to 2.303 by 90 log 65.5 divided by, what's the value? 49.5. Okay, so the answer is 3.11 into 10 to the power minus 3 minute minus 1. Okay, so the next value is K is equal to 2.303 by 230 log 65.5 divided by 31.75. So after simplifying, you'll be getting 3.18 into 10 to the power minus 3 minute minus 1. Okay, students. So we have found out all the K values for different time intervals. Is it not? See, check the values now. The first value is 3.06, second value is 3.11, third value is 3.18. Only make a difference. Almost all the three values are similar. Is it not? Since all the rate constants are similar, we can come to a conclusion that this reaction is a first order reaction. Okay, since all the values are similar, we can come to a conclusion that it's a first order reaction. So the next one is we should calculate the rate constant. Is it not? How to calculate the rate constant? Just add up all the rate constant and divide. You should find out the average. Okay, so 3.06 into 10 to the power minus 3 plus 3.11 into 10 to the power minus 3 plus 3.18 into 10 to the power minus 3. Then you should divide all these three values by 3. Okay. So you'll be, after simplifying, you'll be getting 3.12 into 10 to the power minus 3 minutes minus 1. Okay. Understood, students? This is the answer. This is how you should find out the rate constant for a particular reaction. And the temperature coefficient for the hydrolysis of ethyl acetate by sodium hydroxide is 1.75. Calculate the activation energy of the reaction. See here, they have given the temperature coefficient for the hydrolysis of ethyl acetate by sodium hydroxide as 1.75, and they are asking you to find out the activation energy of the reaction. So first of all, you should know what is temperature coefficient. So actually it is used to describe the effect of temperature on a rate of a reaction. Okay. Actually this temperature coefficient of a reaction is defined as the ratio of the rate constants at two temperatures differing by 10 degrees centigrade. See, okay. See, two rate constants will be there, and those two rate constants will be differing by 10 degrees centigrade. So if you are taking a ratio between those two rate constants, then that will be the temperature coefficient. Okay. Let us consider. We shall consider temperature 1 as 298 Kelvin, okay, and temperature 2 as 308 Kelvin, okay. See, if you are checking the difference between these two, then it is 10 degrees centigrade, okay. 10 degree centigrade is that. So the rate constants will be, we can take the rate constant at T1 as K1 and rate constant at T2 as K2, okay. K1 by K2. So this also you can write as K298, and this can also be written as K308. Okay. Now we shall write down the Arrhenius equation. What is temperature coefficient now? K2 ratio between K2 and K1, that is 1.75. Understood? So now I am going to write the Arrhenius equation. Log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T1 T2. Understood? So we know that K2 is this one and K1 is this one. Is it not? So now we are going to substitute. What is K2 by K1? It is 1.75. Is it not? So log 1.75 is equal to EA by 2.303 R into T2 minus T1 by T1 T2. Okay, now I'm going to substitute all the values. Okay, so what is the EA? We do not know, by 2.303. What is R? It is into 8.314 into T2 minus T1. What it is? 308 minus 298 divided by 298 into 308. Okay. Now we are in need of EA. Okay. So what is EA? You can convert this 2.303 into 8.314 into 298 into 308 into log of 1.75 divided by, what's the difference between these two? It is 10, is it not? So when you are substituting log value and finding out the answer, it is 42711.5 joules per mole. Understood? So if you want to convert this into kilojoules, you should divide by 1000. Okay. So 42.711 kilojoules per mole. Understood, students? So this is how we should do this type of problems. Fine, students, you might have understood all the problems we have seen in this part 2 video. If you are having any doubts regarding the formulas, you can see my video on formulas and units. The link for the same is given in the description box. Okay, students, I shall meet you with an interesting and important topic in a short period. Until then, it's Anita Raj signing off from you. Thanks for watching.